Hello, everyone, and welcome to today's course, part of Smart HVAC series, Indoor Air Quality Best Practices, with Rich Caro. My name is Sarah Kleppel, staff writer with Buildings, and I'm very pleased to welcome you to this course. I'd like to begin today by thanking our sponsor, Mitsubishi. Please be sure to visit their website. Before we get started, I'd like to conduct a brief polling question. Please enter the total number of people watching this course, and please make sure to include yourself. To answer the question, simply select your response and click Submit. Thank you. We encourage you to ask questions during the presentation. To ask a question, click on the Q&A icon at the bottom of your screen. Although you may submit questions at any time, most questions will be answered at the end of the presentation during the Q&A session. Should you experience any technical or audio difficulties during this broadcast, please send a message in the Q&A box or contact us at 800-553-8878. You may enlarge the slides at any time by clicking the expansion icon on the media player. As an important reminder, you may also access a copy of today's presentation slides on the Business Resources tab on our website. On behalf of Stanmeets Communications, Inc. and Buildings, we are pleased to announce today's course is worth one Health, Safety, and Wellness hour of credit with the AIA for Continued Education. Here you can find your provider number as well as the course number. It's also approved for one CPD credit from BOMI International for our RPA, FMA, or SMA designation programs. Following the course today, you'll be directed to the Buildings Education site where you can submit for credit. You must be present for the entire course to gain credit. Now, let's review our learning objectives for the day. They are to learn how HVAC can IAQ, review methods for IAQ measurement, such as carbon dioxide levels and relative humidity, determine mistakes to avoid when managing HVAC and IAQ, understand the best practices for managing your HVAC system to achieve healthy IAQ. And now I am pleased to introduce today's presenter, Rich Caro. Rich Caro is John W. Danforth's Filtration Accounts Manager, who specializes in air filtration product knowledge, indoor air quality initiatives, and management plans in commercial spaces. Rich is a certified air filtration specialist and is NAPA certified technician level 2. Rich has 20 years of experience with indoor air quality, airflow, and filtration, and brings a wealth of knowledge to helping facilities managers understand the best needs for their buildings. Thank you for joining us, Rich. I'll let you take it away.
Thank you very much, Sarah, and good afternoon to all of our attendees. Thank you for joining us. What I'd like to do is just kind of talk a little bit about the goal that I have for today. Today, I'm kind of going to go over a brief overview of indoor air quality, and my intent is that no matter what stage you're in terms of an IAQ plan and an HVAC maintenance plan related to IAQ, that you can walk away with at least one or two things that maybe you hadn't thought of, or things that you realize you could maybe do a little bit better or focus on a little bit more. We're not going to be able to, in the time allotted, take any deep dives into any specific pieces of this, but the intent is to give you an overview of it. Without further ado, the agenda that we'll be talking about today, as you can see on your screen, a very quick overview. What is IAQ and what are some of the components of it? We're going to talk a bit about some of the sources of what I call IAQ detractors. We're going to talk about the goals and benefits of good IAQ. And then if you haven't heard about this, we're going to talk a little bit about what is PM 2.5. You'll learn a little bit more about that in a few minutes. And we're going to dig into just a little bit about IAQ measurements. We're going to talk about the major components of HVAC systems, heating, ventilating, and air conditioning systems, and what their impact is on IAQ and how they can impact it. We're going to briefly discuss air duct aseptics. If you don't know what that is, you will by the end of this presentation. We're talking about some of the common shortfalls in HVAC maintenance, and then some of the best practices that our company has learned and that the industry has learned over the years. And then just a broad overview of air filtration and some suggestions on the type of guidance that you should be asking for and receiving from your filter providers. And then we'll wrap it up and certainly address any questions that the audience has. So indoor air quality, I lifted this from one of the publications from the Environmental Protection Agency, and this is used fairly commonly across the industry. Indoor air quality refers to the air quality within and around buildings and structures, especially as it relates to the health and comfort of building occupants. So not just comfort, but also the health. Understanding and controlling common pollutants indoors can help reduce your risk of indoor health concerns. And one of the key pieces of data that I like to bring up that many people don't realize, indoor air can be 5 to 10 times more polluted than outdoor air. So when we say, you know what, we're going to take a walk outside to get some fresh air, that's kind of the concept behind this. And that's an important note. So we need to treat it very seriously in the way that we're managing our HVAC systems and all of those components that can affect good indoor air quality. There is a plethora of material out there, published material from many different agencies on indoor air quality and ventilation for commercial, residential buildings. One of the best ones to start with, if you don't have any publications in your library within your facilities, is the ANSI ASHRAE Standard 62.1, Ventilation for Acceptable Indoor Air Quality. This particular reference was published in 2007, and then again in 2016 is the most recent version. There have been errata and addendums published to it as well that affect certain pieces and parts of it, but that's a good standard to start with, and there are many others. So that's a brief description of what IAQ is. So when we talk about indoor air quality, what are the components of it? We're talking about, obviously, temperature and humidity, two of the things that we all recognize when we work in occupied buildings, but also CO2 or carbon dioxide, odors and gases, viruses, bacteria, and molds and other contaminants, VOCs, volatile organic compounds, if you're not familiar with that particular term, particulate, such as dust and allergens. And this is just a short list. There are certainly many other components that we could look at, things like radon and ozone. The list can go on and on. It depends really on the type of facility, where you're located, what's around your buildings, in terms of what's important to the indoor air quality in your particular facilities. But this is a good short list to start with. So now we know what comprises indoor air quality. What are some of the sources? Some of these things that negatively impact indoor air quality, where do they come from? Most of these you would see as fairly evident. Some you may not have thought of before, and this again is not a finite list. There are many other things, but this is a good broad brush list of those kinds of things, those kinds of sources. So we talk about indoor sources, things like copy rooms, paper fibers from copy room, those are going into the air and being aspirated into the lungs and can certainly affect our ability to have good respiratory success throughout the day. Dust trafficked in our clothes and shoes. We don't realize how much dust we carry in. We are essentially walking filters when we're walking outside. The clothing that we have on, the shoes that we wear, the gloves and the hats, All of those are filtering the air, and that air is comprised of dust particles and pollens and all kinds of things. And we're filtering those out, and we're bringing them into the spaces that we work in and that we live in. And as we take those coats off and those hats off and we take the shoes off, we're stirring those dust particles up, and they're becoming airborne. So they're becoming part of our indoor environments. Cleaning chemicals. There are certainly a lot more cleaning chemicals available in the market today that are low VOC or odor emitting, that are non-toxic, non-hazardous. Certainly we're in better shape than we were 10, 15, 20 years ago. But those cleaning chemicals are still leaving or introducing into the air in our indoor environments a certain amount of VOCs and odors. New carpets, floors, furniture, whenever you're having your facilities renovating and you're bringing these things in. And again, there are many low VOC emitting products available in the marketplace now, so that we don't exacerbate the problem. But there is always going to be at least a certain level of VOCs and odors emitted from all of these types of products. Cooking odors. If you've got kitchens, whether it's a small kitchen or a large commercial kitchen in your facilities, you've got cooking odors. Sometimes it's just at lunchtime. Sometimes it's throughout the day if you've got a large facility that's serving meals throughout the day. And it's not only the odors. Cooking can also create particulate in the air. There are some scientists that recently presented at the National Air Filtration Symposium that talked about the idea that measuring particles during cooking, they're seeing a significant increase in particulate in the air during lunch times. So something to keep in mind. Little things like dry erase markers, glue, paint. If you're repainting your office, is certainly a lot of VOCs. And again, a lot of low VOC paints available. If you're hiring contractors to do painting in your building, that should certainly be one of the questions, one of the interview questions. What types of paint products do you use? Dry erase markers today. You can remember in years past, very strong and pungent odors from those things. Those markers that are available today, typically a lot lower odors and VOC emissions. Outdoor sources, air carried particulate, highway sources. If you're near a major highway, there is a lot of dust and particulate being stirred up by those vehicles. And that once that dust is in the air, depending on which way the prevailing winds are headed, they may be headed right for your air handling equipment, your HVAC equipment on the roof. And so if you don't have proper filtration, that particulate is making its way into your indoor spaces. Farmland. We see this all the time, especially in rural and agricultural areas in the springtime. When the farmers are starting to turn over the sod, when they're starting to apply manures and other treatments to the soils, those odors, and especially if it's been a dry spring and when they're doing the plowing in the late summer when it's dry after the first cutting of hay, there is a lot of particulate being thrown into the air when they're doing those, and certainly the odors. There are ways to handle that, but we need to be cognizant of what's happening outside of our buildings so that we can properly impact what's happening inside of them. Loading docks. In the past, we haven't done a great job of reducing those odors from diesel and gasoline fumes. I'm seeing a lot better treatment of it these days at loading docks where there's a proactive approach, and even those transportation companies are teaching their drivers to turn off their vehicles when they're unloading. When they don't, that is a significant source of VOCs being drawn right into our buildings. Construction dust and odors. If you're having renovations done on your building and certain parts of your buildings, you should be cordoning off those areas, at least with heavy-duty multi-mill plastic sheeting to keep the dust from migrating into the other parts of the building. In most commercial construction projects these days, it is recommended and required that negative air machines or these blowers, these exhaust fans with HEPA filters on them, are used to create what we call a negatively pressurized space to keep that dirty construction air on the construction side and not allow it to migrate into the occupied office spaces. Something to keep in in consideration as you're planning renovations and as you're interviewing the contractors that are going to be doing the work. Make sure they have an IAQ plan. And then certainly the odors are part of that too. If you're having a roofing job done, if you've ever gone through one of those in your buildings, you know what I'm talking about from those roofing products and the sealants that they use. Very strong odors, lots of VOCs. There are solutions for that. It's a short-term project, so you don't need to put permanent solutions in place for it, but there are solutions, different types of odor-removing filters that you can place inside of your HVAC equipment during those projects. And then air quality alerts. I bring that up just to alert you to the idea that, again, I talked about understanding what's happening outside of our buildings so we control the impact of it inside. And when there are air quality alerts issued by your local agencies in New York State, it's the DHCEC that does it. This is talking about something called PM 2.5 that we'll talk about a little bit later. So understanding if it's going to be a high air quality alert day, that you need to make sure that you've changed your filters and your HVAC systems and that you're prepared for that. So what are some of the goals of a good indoor air quality program? Certainly the first and most important is healthy indoor environments. We want our workers to leave at the end of the day of work no worse off and hopefully better off than when they started the day. So we don't want them to come in and operate in an unhealthy environment all day. That's going to end up causing illness and absenteeism, all of those things that can affect the bottom line of a company, but also impact our employees, and we care about our employees. Temperature and humidity consistency, we see this all the time. As buildings are being renovated or expanded, oftentimes there's no plan to go back through and rebalance that particular building. And so what we end up with is the new spaces have all the more sophisticated temperature and humidity controls on them, but the old spaces now have been impacted by all the new equipment and the repressurization of the building. And so we have very inconsistent temperature and humidity from one corner of a building to another. A lot of times it's because of air balancing, air and water balancing, and we'll talk about that a little bit later. Minimal particulate levels. We want to keep the dust down to a minimum in the office space. And it's not just the types of filters that we use in our HVAC systems. It's also what our house cleaning protocol is. We'll talk about that towards the end of the presentation. Minimizing odors. I talked about kitchen odors, talked about farmland and some of the odors that can come in from the outside loading docks, et cetera. But minimizing those odors so that we provide a pleasant environment that is not going to be distracting workers so that they can't concentrate on the jobs that we're paying them to do. Sufficient fresh air and low carbon dioxide levels. There's a push to reduce energy usage by installing carbon dioxide monitoring in the building so that we can reduce the amount of outside air as long as we're meeting what we call the IAQ test procedure, something that would be a great topic for a future webinar, but we won't get into and drill down into right now. Preventing the spread of airborne microorganisms. People bring flus and viruses and things into the workplace, and we can make an impact on reducing how much those get spread. Certainly the first one is to recommend that our employees take those days off and not bring that into the workspace. But sometimes we don't know that they're sick. They don't know that they're sick, and they're coming in and they're bringing these things in. So how can we reduce that? Well, we can make sure that we've got appropriate air changes in the buildings. We can make sure that we have good, stringent cleaning protocols. We can segregate those employees for that particular period of time. So there are a lot of different things that we can do. Hand washing stations, all of those things. Occupant comfort. It is a big piece of the goal of an indoor air quality plan to make sure that everyone that works in the space is comfortable. But what we know, we all know this, that comfort sometimes, it's always a perception, and it's an individual perception. One person is hot, another may be cold. Maybe where they're sitting, it may be how they're dressed. It may just be that, each person is a little bit different. And so, we can't satisfy everybody all the time in the HVAC business. Not everyone is always going to be as comfortable as they want to be. But what we can do is give them a little bit of visibility and a little bit of control over their environment. I would not recommend putting thermostats in everybody's office because you're going to send the entire system off balance. There are ways that you can give some visibility and control, at least to certain areas of the building. When people have control, they tend to complain a bit less, and they'll find a way to be comfortable. So, high indoor air quality. If you've got a good IAQ plan and you're executing it, what are some of the benefits you're going to see from that? Because let's face it, there's going to be an investment of time, money, resources, if you want to take your building indoor air quality to the highest levels. So there has to be a payback for that. And these are some of the lists. Again, there are other things, but these are some of the items that our company sees as a result of improved indoor air quality in facilities. Occupant comfort, I mentioned that. Reduced absenteeism. If you've got fresh air, good air quality, it's less likely that you're going to have high absenteeism rates, which obviously means you're going to have, you're going to have people in the seats doing the job that they get paid to do. Improved alertness. After lunch, everybody tends to, their metabolism tends to slow down a little bit, and they start to get a little bit sleepy. It gets even worse if we have higher carbon dioxide levels and not enough fresh air in buildings to provide that alertness level. And increased alertness means increased productivity. Tenant retention. If you're managing facilities that you've got tenants as your customers, you know the cost of losing a tenant. If a tenant is consistently unhappy with the indoor air quality, the temperature, the humidity, the odors in your space, when it's time to renew their lease, they're going to think really long and hard about whether they want to stay in your building or not. So tenant retention, big payback. Prospective tenant impression. If you've got folks walking through your buildings considering renting or leasing some of your spaces, and they don't like what they smell, they don't like the way it feels stuffy in here, it seems hot in here, it seems too cold in here, it's drafty, they're probably not going to want to sign with you. So prospective tenant impression is a big one. Employee retention. Not really a big one on the list, but we have seen where if an employee is on the fence about whether they want to stay at this company or not, and if that's another thing on the negative side of their list, it could push them over the edge and help them to make the decision to leave. So employee retention, and we know what it costs to hire and retrain new employees. Visitor first impression. If you've got prospective clients and they're coming in to learn about your company, that first impression, the way your building looks, the way it smells, the way it feels, is really big. And a bad first impression is very hard to overcome. So I'd say that's a big one on the list. So we talked about some of the goals. So let's go back to what is this PM 2.5, because this has become a very prevalent point of discussion in facilities these days. PM 2.5 is a way that we define a group of fine particles that are less than or equal to about 2.5 microns in size. Very small, barely visible. They come from an infinite number of sources. I've listed just a few of them here, but you can imagine. But vehicles, factories, burning, there's so many ways that we generate PM 2.5 artificially. Nature as well generates PM 2.5. And why are these particular particle sizes so important to us? These are small enough to travel deep into the lungs. So we're going to breathe them in. And when we breathe them in and they reach deeply into our lungs, they can trigger things like asthma and other respiratory ailments. They can lead over long-term exposure to chronic illnesses, COPD, all of those other diseases that we hear about. PM 2.5 is the prime culprit for those. EPA standard has listed about 35 micrograms per cubic meter of air as the minimum acceptable, the maximum acceptable level for humans to be exposed. You'll often see a haze in the outdoor air. This is a good indicator that we've reached significant levels of PM 2.5s. In New York State, the Department of Environmental Conservation actually issues a particulate matter health advisory whenever we exceed those limits. So it lets the public know if you have asthma or some other respiratory illnesses, today is probably not a good day for you to be outside, and certainly not to be outside exerting yourself. So it's that important that the EPA issues these warnings and the DEC in New York State issues these warnings. So it's definitely something to be concerned about. And we'll talk a little bit about how we tackle PM 2.5 later on. So what are some of the major systems components in HVAC? Some of these abbreviations, I apologize, I went one slide too far. There we go. So let's jump back and we're going to talk a little bit. We talked about PM 2.5. We're going to talk about indoor air quality and how we measure it. So one of the key methods that we can use to measure it, if you have a building automation system, a DDC control system for your HVAC, your lighting, your power, your security systems, etc. Many times there are already sensors built in gathering data that you have access to. They may only be temperature sensors, thermostats we call them, or wall stats. There may be humidity sensors in the space. There may also be carbon dioxide sensors in the space. So there are a number of these types of sensors that can already be built into your building automation systems. And depending on the types of systems you have and how sophisticated they are, you should be able to accumulate this data and trend it and generate reports so that you can build benchmarking. And you can use that to see the impact as you're looking to implement ways to improve your RAQ. You can also conduct periodic IAQ auditing. You can do it yourself by purchasing certain different types of instruments that can measure things like temperature and humidity, things like particles. There are many different tools out there by companies like TSI and others. Certainly can find those in the marketplace just about anywhere. Or you can bring in a local IAQ contractor, someone who is familiar with indoor air quality, who is familiar with measuring and sampling and auditing buildings, and they can come in and do a periodic auditing for you and provide reports. You can do continuous air sampling. You can put permanent particle sensors in place and CO2 sensors in place. And a lot of those data loggers, we call them data loggers, can transmit that data concurrently to an iPad or a smartphone device or a laptop computer so that you can trend them that way. And the important thing, no matter what methods you use, is that you build trend logs, that you build a history of data, because that's how you're going to be able to sort of steer the ship in terms of indoor air quality in your facilities. Another way, and a lot of people are hesitant to do this, but you can survey the occupants of your building. And I would definitely encourage you, if you are managing buildings that are multi-tenant buildings, that you do that, because you don't want to find out your client's unhappy at the time that they decide not to renew your lease. You want to know that they're unhappy before then so that you've got time to correct the situation and retain them. So don't be afraid to issue a survey to occupants and ask, some poignant questions about how they feel about the indoor air quality in your facilities. Another piece of it, I mentioned it earlier in the presentation, is we need to understand what's happening outside of our buildings so that we can impact what's going on inside. So you should be doing periodic outdoor surveys for source. So in other words, walking around your buildings, driving around in the neighborhoods around your buildings and in the land surrounding your buildings so that you understand what's going on out there. Is there ponding water out there that could be generating algae and mildew and moldy smells? Are the farms starting to turn over the soil so that you need to get ahead of that and make sure that you've got clean filters in place to keep your buildings smelling fresh and clean and keeping the dust out of your buildings? Need to understand if there's construction going on in adjacent buildings or adjacent properties. So getting out there and understanding everything around your building and the outside can help you to protect your building better from that. And then as it regards to air filters, filter testing and inspection is something that is available. If you have a local filter distributor that has a certified air filtration specialist on staff, as an example, they can provide filter testing and inspection services to you as well as consulting services to help you better understand what the life cycle of your air filters should be, when you should change them out, how long they should last. There are also filter monitoring devices out there in the marketplace that can help you with data to tell you when to change your filters and to remind you that it's time to change them, or to alert you to maybe high particle counts. Maybe you're seeing a failure in your filter banks. We'll talk about that in a little bit. So what are some of the major components in a heating, ventilating, and air conditioning system? These are just some of the acronyms. AHUs are air handling units. And we've got rooftop units, heat recovery units, fans. Condensers and evaporators are part of the cooling side equation for your HVAC systems, as are chillers and cooling towers. And then certainly boilers. If you have hydronic heating systems or hot water heating systems in your buildings, you've got boilers. Heat packs or packaged terminal air conditioners. Univents or unit ventilators, especially in school districts. Fan coil units, heat pumps. VAV or variable air volume boxes for zoned heating and cooling systems. And one of the biggest components of your HVAC system is your control system, your building automation system. But we shouldn't forget that part of your HVAC system is also what delivers the air into your spaces, and that is the duct and what we call the terminal devices, the diffusers, the return grills, those things that you see mounted in the ceiling and on the walls that are delivering the air into your spaces. And then there are pumps and other pieces of equipment. So again, not a complete list, but fairly representative of most of the equipment that is part of your heating and ventilating and air conditioning systems. So we're going to talk a little bit about how do you know what you have and how do you maintain it. First, we're going to dig into how these HVAC systems impact your indoor air quality. These are just a few of the things, but malfunction or loss of control or ineffective HVAC systems can impact your indoor air quality. Air and water systems are out of balance. I'd mentioned earlier that if you're renovating your building, if you're making a change to your building, we have to keep in mind that our buildings are systems. They're living, breathing systems. So if we change a part of the system, that can throw the rest of the system out of balance. And so companies like ours provide air and water balancing systems. We typically recommend that if you're going to have an air and water balance project completed in your building, that it is completed by a contractor who is NEB certified. NEB is the National Environmental and Balancing Bureau. These are highly trained individuals that understand the nuts and bolts and the details and the requirements for properly balancing buildings. People think about the air balancing, but they don't always think about the water balancing. If you've got a hydronic heating systems in your building and you've got an imbalance in the water delivery systems that are pushing that hot water into all the spaces, even the most remote office in your particular building, if it's out of balance, you're not getting enough hot water all the way back to that corner office, and that's probably a good reason why that individual always feels cold. A good air and water balancing project can alleviate a lot of those issues and concerns. Molds or mildews, which create odors, harmful bacteria spreads fast. We find this most often in rooftop units and air handling units where we have the condensate pans or drain pans. All the water that is condensing in these units has to drain somewhere. And so there is typically a condensate drain on these units. It can get plugged up, and if it's not part of a regular maintenance program, you won't know about it until all of a sudden you've got ponding water inside of the pieces of equipment that are delivering or trying to deliver fresh air to your space. So understanding that that should be part of a regular maintenance program, you can avoid the buildup of molds and mildews and what we call biofilms on the coils inside of those air handling units and rooftop units, and prevent that bacteria from growing and then spreading into your ductwork and down into your spaces. Air reentrainment from exhaust fans. If you've got an exhaust fan from whether it's a restroom or a kitchen or maybe a workspace, and that air is being exhausted up to the roof space, and it is near the fresh air intake for a rooftop unit or an air handling unit, those odors are being drawn right through that unit and will make their way right down into your space. There are ways to correct that problem. It might be a different exhaust fan, higher velocities, or you can use carbon filters in your air handling units to absorb some of those odors. Collapsed and poorly installed filters, we see this all the time. Dirty air leakage around your filter racks and air filters. And then soiled air duct and diffusers from construction or aging. And it's recommended by the NADCA, which is the National Air Duct Cleaning Association, that every 5 to 7 years a commercial building should have a duct cleaning project or at least an inspection done. So those are some of the ways that your HVAC system can impact the indoor air quality in your building. So as I alluded to, duct tape septics, NADCA recommending that you inspect as a minimum every 3 to 5 years, and that you clean the ductwork in your systems every 5 to 7 years. It's a recommendation. It's not a requirement. It's not a guideline, unless you make it so as part of your IAQ plan. But we recommend you consult with a NADCA certified air duct aseptics firm. Very important that when you're going for contractors that you look at their qualifications. Duct aseptics can certainly improve indoor air quality. And it can also reduce the air friction and energy use. A clean duct pushes air through it a lot easier, uses a lot less energy. Uncovering any leakage or disconnected duct. When you have these duct inspections done, I can't tell you how many times we have found that buildings that are 5 to 10 years old, we find duct that was never connected during the construction process, and we're dumping conditioned air into the ceiling space and wondering why we're not getting conditioned air down to the space it was supposed to go to. And then one of the other recommendations in the industry available to you today is one particular product, and there are others too, but AeroSeal for reduced leakage. This is an interior sealing of your ductwork. So it's a seal that is applied that can reduce leakage and increase energy efficiency. So it's another thing to consider. So why do all these things happen? Why do our HVAC systems that are supposed to give us fresh air cause so many problems? These are some of the things that we see in the field as we're working with customers. First thing is, a lot of times there is no detailed inventory list of the equipment. Nobody knows what the model number and the serial number is of each piece of equipment they have, or maybe the information is outdated. They don't know how many filters and what size. They don't know what size belt or what size pulley or shiv. Very important. A lack of defined tasking for equipment. So if you have a car, there are recommendations for when you should change your oil and check your brakes and all of those things. So those lists also apply to HVAC equipment. So if you don't have a good defined list of what needs to be checked and serviced when on your HVAC equipment, you should be reaching out to the manufacturers of that equipment and getting those lists. Frequency of servicing. You can't just let an air handling unit run for a year straight without any servicing. Improperly trained or insufficiently qualified staff. Sometimes, we ourselves get into what we call the warm body syndrome. You need a maintenance man, so you hire the first person that is able to work. If they're not properly trained and you're sending up to work on these pieces of equipment, they're not really prepared to do that job for you. Self-performed maintenance with inadequate staff. Sometimes companies will try to cut costs, and instead of having contractors come in and do the work, they'll try to perform it themselves. And if you've got qualified staff, absolutely, that's a good way to head. But oftentimes you don't have that. Choosing contractors solely based on price. Overextended equipment life due to budget. Poor quality HVAC filters, belts, and parts. Selecting your filters by cost only. All of these things our companies have, they're trying to do the right thing for their stockholders and their shareholders and to help to make their company profitable. And so they look for these ways to cut costs. And you'll find that oftentimes you're not saving any money, you're spending more. And then filter changeout, we'll talk a little bit about that. So what are some of the best practices? Well, the first thing I recommend, if you don't already have one, select internally or hire a champion for your systems. Someone that has total responsibility for your HVAC systems, which includes all of the things we talk about, the controls, the equipment, the ductwork, all of it. Put them in charge of it. Develop an IAQ plan if you don't already have one. There are many templates out there. You can find them on the internet everywhere. Plenty of good templates for building an IAQ plan. And then as part of that IAQ plan, you should have a good maintenance plan if you don't have one already. And that maintenance plan should include, as a minimum, a complete inventory of all of your equipment, an assessment of the readiness of your HVAC staff, a decision whether you're going to self-perform all or some of it, or whether you're going to contract that work out. And then if you're going to contract it out, develop a detailed scope of work so that when you go out for bids or quotes, you understand exactly what you're getting from each contractor. And then when you hire contractors, they're going to provide you, if they're a good contractor, with a technician report at the end of each scheduled service. You need to review those reports frequently and verify that they've done what they said they've done. And absolutely record all maintenance on all equipment, no matter how small that piece of equipment is. That's a detailed record of the last time you fixed it. And if you find that that same piece of equipment is requiring repairs frequently, something's wrong and needs to be uncovered. Meetings with your staff to identify training and tools needed. Use the right tool for the right job. If your staff doesn't have the right tools and you're sending them up there to perform maintenance on pieces of equipment and they don't have the right tools, they're not going to be able to do the job properly. Duct visual inspection and cleaning. We talked about that earlier by a NADCA certified agent. Retro commissioning and air balancing. I talked about air and water balancing a few minutes ago. Retro commissioning is if you've had a project done in the last couple of years and you're not sure that maybe it was commissioned properly or started up properly, you can bring agents in to do what we call a retro commission, to go back through and see what the design intent was for the system, to measure all the flow outputs on the air and water side, and to tell you whether it's meeting the original intent of its design, and maybe to uncover some of the reasons why you're having those IAQ issues we talked about earlier, like inconsistent temperature and humidity. TCOD for air filters, that stands for total cost of ownership diagnostics. A good air filter distributor with a CAFS on staff, as we talked about earlier, will be able to provide you an analysis of one filter against another to show you the total cost of owning that filter. It's not just the cost of the filter. Equipment protection filters. Protect those chillers and cooling towers from things like airborne debris and cottonwood. Up in the Northeast, we have a lot of cottonwood this time of year. clogs up the fins and coils. Consult with a certified air filtration specialist and learn more about air filters. They're your last line of defense before that air makes its way into your building. This is just kind of a broad brush look at the various filter categories that are out there: high, medium, and low efficiency filters. If you're selecting your filters based on cost, you're probably buying mostly low efficiency filters. Well, they may not be doing the job you need them to do. You may need to move up to a medium efficiency filter. And what you may find is that medium efficiency filter, although it may cost a couple of dollars more than the low efficiency, is keeping your coils cleaner. It's reducing the energy usage in your air handling units and your rooftop units, and it's providing you better indoor air quality. So what is the true cost of that filter? Filter monitoring systems, I mentioned earlier in the presentation. We touch on this a little bit. There are various pieces of equipment and instrumentation available to you out there. One of them in particular, this product is made by American Air Filter. It is a good one. It's a filter monitoring system called the Sensor 360. It's based on the Internet of Things. So there's a gateway, sends the information up to the cloud. You can see all of the data that it's pulling from the pressure drop or resistance across the air filters in your units, and from the 3 different particle sizes: PM1, we talked about PM2.5, and then PM10, which are larger particles. It's measuring that and trending it for you, and you can see it on your smart devices, on your laptops and desktops, and you can trend all that information, and it'll give you a better look inside your filters so you're changing them out at the appropriate times, not too soon and not too late. And another big thing, get control over your controls. I hear this all the time from customers. Well, we have a building automation system, but we can't see inside that system. We have no access to it, and we don't know how to read it. So if you don't already have login and username and password for your control systems, and you don't have that piece of software installed on your computers, you need to jump on that and get it. It's your system. So get access and training on it so you understand at least how to look at the data that's in there, and as a bare minimum, how to control some of the basic set points in that system. And if you've got low confidence in your controls contractor, and we hear this a lot, you need to let them know. You need to call them to the table, and you need to hold them accountable. Let them know, you know, we're not comfortable with you right now. And if they don't seem to want to do anything about it, you should start looking around for another contractor, because you need to be confident that they're doing what you expect them to do, because that control system is a major component in your HVAC systems and in your IAQ. You've got a lot of sensors out there in their systems, and they need to be checked and calibrated frequently. You should do a periodic review of night setback times and set points. Your business operations hours may change. Things may change in your building. Add more sensors if you need them. Sensors are very inexpensive in terms of the data that they can provide you and your ability to make some smart decisions based on having more data, whether it's adding CO2 sensors, whether it's adding particulate sensors in certain areas of the building, or adding more temperature sensors so you can get a better averaging. Some additional suggestions. Review your housekeeping standards. That is actually a very important part of your indoor air quality plan, or it should be. The cleaner you're keeping the carpets, the desks, the bookshelves, the walls, the less particulate there is floating around in the air, and the better air quality you're going to have. Your air handling unit is only going to filter the air that it sees brought back to it through return air, and it's only bringing in a certain amount of return air back from your space. So it's not going to do the job of cleaning the air down in the space for you. Consider tacky mats between warehouses and offices, especially in a manufacturing environment. Keep that dirt in the warehouse. Keep it back in those manufacturing areas. Don't track it through the offices. Increase air change rates if you have control over your BAS system and you have the ability to increase the amount of airflow that's going through your space. Increase it during lunchtime. We talked earlier about the particulate and the odors created during lunch. So you don't want those to spread through the building for the next 3 hours of the day. If you've tried everything else and you're still having hard particle counts or maybe significant odors in your building, you can always go to a fixed or a portable air purifier that has a HEPA filtered carbon filtration in it. Monitor the weather so that you can adequately plan your maintenance coverage. If you know you've got some high degree days or extremely hot and humid days coming up, you're probably going to have some indoor air quality complaints because of the temperature and humidity. So have one or two extra maintenance people on staff so that they can react to those. If one particular area is suffering from extreme heat or humidity, go up and check the filters. Maybe they do need to be changed. Another idea, tie your IAQ to financial goals for your organization. If I improve the indoor air quality in my building, I'll reduce absenteeism, which results in more productivity in the workspace. Tie that to some kind of a financial goal. That's, really has to be between you and your business officials. But you can tie those things in so that they're important to the financial goals of your company. And you can also use your IAQ focus as a marketing and recruiting tool. When you're out there at trade fairs and you're trying to recruit people to work for your company, especially the younger generation, they're very interested in things like indoor air quality. They're very interested in their health, and they want to know that companies care about that. So that may be a very big draw for them. And certainly marketing. If your customers know that you care about your employees enough to provide good indoor air quality, they're going to expect that you're going to treat them even better than that. And that could be a very big marketing tool for you. So at this point, that concludes my presentation. And at this time, I'm certainly open to take any questions that we may have.
Yeah, thank you for that informative presentation, Rich. We'll now begin our question and answer session. Attendees, if you haven't done so already, please submit your questions by clicking in the Ask a Question box on the left-hand side of your screen. So our first question is, Rich, is there any statistical data to confirm and support high IAQ benefits?
So data to support high IAQ benefits. There are a couple of organizations that have done studies. In New York State, for example, we have something called the IAQ Tools for Schools program. And one of the things they've done through a couple of private agencies, and I can certainly get access to that data for you, is they've taken a look at what happens in student absenteeism with poor indoor air quality in schools. So that's one particular area. The LEAD program, the Leadership in Environmental and Energy Design, Energy and Environmental Design, through the U.S. Green Buildings Council, has a lot of published reports out there that prove that there is a tie-in, a direct tie-in between good indoor air quality, good ventilation practices in healthy buildings, and things like employee absenteeism and employee productivity. So there's a lot of statistical data out there, a lot of different organizations, and a great source of that is the National Air Filtration Association. They have a technical seminar, and they also have a convention each year in different places in the country. And certainly attending that would be a great source. We have papers, white papers being presented there all the time on exactly that topic. Thank you for that question.
Yeah, thanks, Rich. Next, so I'm trying to achieve a balance between efficient energy use and comfortability for the occupants. What is your recommended heating and cooling set points for an office environment in a commercial building, or amount of adjustability / control for the occupants?
Yeah, so that's a great question. So, we've got a big balance there. What you're talking about is how much energy do we expend, and at what cost to keep our building occupants comfortable, and then how much sort of latitude if we do give them some control over raising or lowering the temperature in the space. We generally recommend, a set point of 68 to 72 in terms of temperatures. We're in the Northeast, so that usually works out very well for us. And then if we give them, 2 or 3 degrees either way that they can adjust it up or down, that usually works pretty well for them. But what we normally do is we pick a zone and sort of pick a champion for that particular zone. It might be the office manager, it might be somebody that that's in more of a leadership position there. Because if we give control to anyone and everyone in that space, you're gonna end up with all kinds of balance issues. And then we also often have it locked so that only that particular individual has access to it. We just make sure that it is understood and known that anyone can go to them and request that the temperature be increased or decreased. And in terms of humidity, those set points, we know that anything below 40% relative humidity, we start to see static electricity issues. So if it's an area where there's a lot of sensitive electronic equipment, we want to stay above that. But on the high end, and that's where we run into the problems, anything over about 70 to 75% humidity, seems to be a little bit too high. And we can accommodate that by simply subcooling the air in the air handling unit to dry it out a little bit. Thank you for that question.
Great. Next question, what temperature set points would you recommend for nighttime setback/setup?
Great question. So when we talk about night setback, it depends on what type of an environment it is. So for instance, if it's a warehouse environment and you're not storing anything that is going to be harmed by dropping the temperatures, you can drop them down to say 60 or 62 degrees at night. But if you're talking about an office environment, if you want to drop it down to say 63 to 65 degrees at night, you're going to have to make sure that there's enough ramp up time when you spin that back up in the morning so that it's reached set point before everyone comes into work. So if you're starting shifts at 7 o'clock or 8 o'clock in the morning, you may need an hour or so to ramp that back up. So as well as what set points, the time interval that you spin it back up and turn it off night setback is just as important. Thank you.
Great. Next question. What is your opinion or experience with bipolar ionization for air purification?
So we've had some experience in implementing bipolar ionization systems. We did a couple of local jail projects with this. And I know what the data shows, and I've seen some reports that show that bipolar ionization can reduce things like VOCs, can reduce carbon dioxide in the air, essentially converting some of those elements into oxygen molecules, oxygen radicals, and that it can affect the particulate and cause particulate to fall out of solution in the air, and thereby reduce airborne particulate levels. We've seen mixed results with that, and I think part of the reason for that is on the maintenance side of it. Most bipolar ionization systems require change-outs of the corona discharge tubes roughly every year, and it seems like almost exactly to the day of the year those things fail. And if a customer is not on top of that, does not have a good maintenance program, that's when those start to fail. And that's just like any other instrumentation that we use. If it's not maintained properly, it can't do its job. So mixed results, but mostly because of the maintenance side of things. But we don't have enough installations out there yet to really form a detailed opinion based on the data. Hope that answered your question a little bit.
Great. All right. Well, that's all the time we have for questions. Thank you for answering them, Rich. That was a great job. Now, before we close out, before we close out this presentation, there are just a few important pieces of information we'd like to share with you. Please join us for our next course on June 11th at 1 p.m. Eastern Time, The Benefits of Energy in Domestic Water Submetering. Then join us again on June 20th for our course titled Free Cooling Fundamentals for Data Centers. We hope you can join us. Don't forget that you can find our past courses on our website, available for you to view at any time. We have dozens of building-related topics. Visit our on-demand courses today and watch now. Be sure to stay connected to buildings by visiting us on Facebook, Twitter, and LinkedIn. And as a reminder, a copy of today's presentation slides are available by clicking on the Resources tab. And thanks again to our sponsor, Mitsubishi. Please be sure to visit their website. Thank you again to today's speaker and to all of you for joining us today. You will now be redirected to the building site where you can view other educational courses offering ideas and solutions for your everyday problems, as well as submit for your continuing education credit. Have a great day, and we'll see you again soon.